name is Paul DiGiacobbe. I am the Director of Geospatial Services at Major Consulting. We chose this ADA ramp compliance topic because we believe it's very relevant this day and age. A lot of folks are scrambling to get things done. So we look forward to having a nice short educational presentation. So again, thank you again for joining, and we'll go ahead and get started. So I think the first thing to talk about is a little bit of background on the topic, ADA compliance. What is it? Where did it come from? So a lot of you probably know about this, but Title II of the ADA, the Americans with Disability Act, it prohibits any discrimination against qualified individuals that need to gain access to public services and entities like most of you probably come from. I think the thing that we're going to focus on is the ADA ramp side of that business. There's a lot of subject matter around compliance, but what we're really interested in and what we're hoping to demonstrate today is how you can handle the ramp, the geometry of your ADA ramps. And then the term ADA compliance is kind of floating around as a accepted term, and really what it means is your standard of providing those services. How do you make sure that the ramps that you govern are in compliance? And we're going to give you some examples of how to do that today. I think the most notable thing is that if you're not worried about ADA compliance, there's a lot of litigation happening these days. There's many examples that have been cited where either individuals have sued or the Department of Justice could come down and levy fines. So it's an important topic. We believe it's a difficult thing to do with conventional means, and we believe we have an interesting solution to share. So when you talk about the ADA and the Title II information related to ramps and the standards for design, there's a lot of information out there that you can research. This is a summary of some of the things that you're typically going to have to adhere to. You know, it's really about the cross slopes of things, the ramp slopes, the width, the areas of landing. All those things are very important, and they need to be measured for compliance. So this is something that if you haven't done it, you can go out onto a lot of the government websites, and this information is published. The ADA has published it. There's manuals that you can download if that's something you really need to dig deeper into. I would assume most people on this call are aware of these standards, and the question is really more about how do you get it done? How do you make sure that all of these design specifications are being met? So we'll talk a little bit about how that's done. So traditionally, this type of compliance effort requires a lot of people on the ground. And they're taking measurements with smart levels and tape measures and basically recording that information into a mobile device, or maybe it's a pad and paper. But this is kind of the current standard, and what we believe that there's a better way to do this. Most folks probably have to put an army of manpower out there for a reasonable size municipality or county or district of a DOT to make this type of measurement happening. And then the question is, how do you keep that data secure? How do you make sure that you've got legacy information that you can refer back to over time? I believe that's where some of these procedures can be a little bit more cumbersome. So what we're recommending at Major Consulting is using the advent of mobile LiDAR to really expedite the survey side, right, and rapidly survey many curb ramps at one time. The image that you're looking at there is an example of a mobile mapping system. And what that equipment really does is it's a combination of laser scanners, cameras, and GPS or navigation. So what we're doing is going out there and collecting millions of points at a time, many points being measured. We're also collecting calibrated imagery. And what I mean by calibrated imagery is the imagery is tied to the GPS of the system, and it can represent itself in the same 3D frame as the points themselves, which makes it very easy for a technician or analyst to look at that information after it's been collected and make an assessment from it. So we believe that this is a much better way to go get all that data in one or two field days, collect a tremendous amount of information, and then take that data into the office and start to process it. So this is the way we believe we can get a lot more done in a short amount of time. And then if the project is big enough, we believe we can save you significant amount of money and really expedite the schedule on these things. So that's kind of the approach that we're taking. We think it's worth sharing. And I'm going to get into some of the details of how we do that over the next handful of slides. So once we're done with the mobile collection, driving the truck around through the town, the city, the county, district, for example, we then create this point cloud. And what you're looking at there is an intersection where it's 3D scan data that came from that truck, and it's also the image qualities, the RGB of each pixel has been applied to the point cloud. So you really get a colorized 3D image of what's physically in the field. So we take that data and we bring it into the CAD environment, and then we use a specialized software that can handle these millions and millions of points on screen, and we begin to do our assessment of the ramps. We're working truly in a full 3D environment, so we're able to kind of move around and change our vantage point to look at the specifics of any specific ramp. And the software tools that we use really do allow us to do a rapid assessment. We're using templates to do that, and I'll talk about those in a minute. But when we're done, the output from this is really either a piece of CAD information about any specific ramp or the tabular data that has actually been derived from all the measurements that were taken. There's key measurements. If you go back to the Title II design standards, all those slopes can be measured, all those ramp widths can be measured in a rapid fashion and presented in a tabular format. That tabular format can go to a lot of places, right? Excel spreadsheets, databases, things of that nature. And that's really where the solution becomes unique for each one of our customers or clients once we're done with the work that we do in the office. So I guess the end story in this assessment process is that we're actually able to expedite a tremendous amount of work, high volume results in a short period of time. So let's talk a little bit about the actual modeling that's done. So what you're looking at here on the left is a calibrated image, also being shown at the same time as the vector data that's been extracted for a particular ramp. On the right-hand side, that's actually the point cloud. So, and you're looking at a template. We create templates that are kind of standard to the different types of ramps. And those templates get applied, chosen by the user, and applied to the point cloud. And then they really just make adjustments to those vertices. You can see the blue vertices are really what we're adjusting and snapping down to the corners of the critical elements and really that define the 3D model of the ramp. So once we're done with that, then we basically just run a tool that pulls the key information that need to be measured between those vertices and between those linear elements within the CAD environment. And then that gets reported out into a tabular format. Let's take a look at the tabular format. So when we're done, and again, this picture on the right kind of shows you all the things you may want to measure, right? The landing widths, the running slopes, the different elements that really make up the key pieces that you may be interested in. And that information, once measured, is put into a tabular form. As you see on the left-hand side, it really is just a spreadsheet, a tab in a spreadsheet. And as you see in the upper left-hand corner of that spreadsheet, this is the northwest ramp number 1. There could be 2 ramps per corner, maybe sometimes even more than that. But generally speaking, you're going to have between 4 and 8 ramps at an intersection, and they can be named accordingly to where they physically are in space. So we're now reporting on the slopes, the widths, dimensions, all those things that were laid out by the template are now reported on and built into this tabular form. We also can produce the CAD files. So what's interesting about that is that if you were out there just with a smart level and a tablet or an iPhone or something like that, you may have some information about your geolocation, but what you're getting from the point cloud data is an actual physical location. It knows where you are in the world. So that information can then be mapped, right? So we can look at, you can imagine a CAD drawing with all of your ramp templates. If I go back a slide, you could have a 3D drawing of every ramp of every intersection in a CAD drawing. That could be a typical output. But what's probably more important is the ability to take that into some type of a database, right, or spreadsheet type of environment. And then you can assess whether or not the values that you are extracting from the information are meeting the spec, right? And then you know if you have a pass or a fail type of situation for a particular ramp. So it's really important to remember that once the work is done in the field and we assess it in the office, we can produce a variety of outputs depending on what your particular need might be. And it's really important to recognize that each ramp gets a report, and then you have a geospatial reference, which really defines the location of that particular ramp or at the time that we collected the data. So the next logical step after you've done this collection and analysis and extraction is to then put it on a map somewhere. That's kind of where the GIS role comes in. Most entities, cities, states, counties already have some type of enterprise GIS in place. What we're talking about here is another layer in that GIS. So really what you want to be able to do is review the process, review the progress of that particular work order, right? You'll get, some particular region of a county, and report back to that in a map sense. So you get this web-based overview of the world, no specific software required, really just an internet connection. And then the review process is available to just about any stakeholder that you might have. That's an important element to this part of the workflow, is that if you do have a GIS and you want to present this information, it makes it a lot easier for folks to review it. The other important thing is if you want it and you need it, you can actually drill down. You see these little red and green stars that represent a ramp that is not meeting the standard. This ramp is meeting the standard. You can click on those and then see that tabular data. It all depends on how your GIS is set up and what degree of freedoms you want to have in the reporting capability for your particular GIS installation. And of course, color coding, knowing, if you looked at this on a, zoom out from this view, you could see all the intersections, you can see the amount of green, the amount of red. That's a very helpful visual cue to how the AD ramps are actually performing for you. I think the next thing to think about is how do you take that information and then prioritize what needs to be done. We all have limited funds and capital investments that are being made to repair these things, but where do you go first? How do you know which ones are the most important one? Maybe you're looking at the most important intersections, in downtown area. They obviously are going to have higher priority, but you could take a look at which ones are passing, which ones are failing, knowing how to really assess what needs to be done. And then when you think about risk of failure, that's another thing that these GIS applications can do, is actually assess that risk. If you should have a problem out there, what does that mean to you? And then adjust your capital plans accordingly. As we mentioned, this is something you can merge with other GIS layers to create kind of like just another piece of the information of all the things that you have to manage in the GIS enterprise system. This could be one of them that you look at. And I think when you look at it from a digital perspective and you think about all this information that's being collected, tremendous amounts of LiDAR data, and then this background assessment that's being done, really sometimes the only thing you want to present are the final results. So that's, I think what we're looking at here is a better way to collect all that in a sustainable way. You could have archived data, from 2020, you do it again in 2022. You can look at the differences in those things. And I think that really gives you a really good lens into the world of ADA compliance as time goes by. So these are some of the critical elements that we think are worth consideration by any entity that has to worry about compliance based on Title II. So I just want to close with some benefits. I think, the one thing I want to make sure folks know is that large areas of coverage can be collected in a short amount of time. The back office effort obviously takes some time. There's, manual, semi-manual, semi-automatic things that you have to do to apply the templates that we talked about. And then from those templates, then we then can do the assessment and the analysis and measurement that really defines pass or fail. So that's a big deal. The other major thing to be taking away from this presentation is the safety factor. I don't like to stand in the street, holding the end of a tape measure. I'm sure most people in this world today don't want to. There's a lot of distracted drivers out there. So just removing that manpower that's required to be at the corner taking measurements is a pretty big deal. And we really move that assessment, that measuring capability, measuring requirements that go into place to do this. We're doing that in the office, in front of a PC, without having to have manpower on the ground and in busy areas. That's an important thing to remember. The digital record and inventory. This is this day and age, it's really great to have things in a digital manner that you can go back to over time and see your progress. We believe that having it collected in a digital manner and then that legacy of information is carried through over time is a pretty big deal, and we believe is a major benefit of this way of doing things. And then obviously just identifying and prioritizing your problem areas. I think you look at a city or you look at a county. There's a lot to consider. I know we've talked to folks that have hundreds of thousands of ramps to be looked at. That's a monster effort, right? And how do you take bites out of that and make sure that you're at least progressing your program to a point where it's making sense and you're in compliance. We believe that this is a way to help with that identification, get it into a map-based environment to help you make your assessments. We also believe that this is a repeatable and reliable turnkey process, really. You just basically say, hey, it's District 3 of the state has to be taken care of, and you go at it. You go get the data and you make it happen in the background. And really the end game is what is your needed output, and I think there's a real potential for cost savings when you look at large areas. I would not deploy a mobile mapper to do, a few miles of city street. This is something that you would do when you have a very large problem in front of you with hundreds or thousands of curb ramps to be looked at. That's a pretty big, important thing to mention. So I think what I want to do now is really kind of open up. I only took about 20 minutes, which is great. Went a little faster than I thought. But we want to really give folks a chance to ask some questions and see if there's something that I've said that has inspired some thought that you might want to get more information on. Before I open it up to questions, let folks know that you can always email us if it's something specific and you don't want to share much about that. You can certainly email us at surveywebinars@majorconsulting.com, and that information will make its way to me or the other geospatial professionals within Major, and we'll provide an answer. And then I also wanted to plug our future webinars. You'll be able to find those. They'll be, of course, always announced via social media, but the Major Consulting website and the events page will be listing the future webinars that are mostly related to survey and geospatial, but we expect other topics coming in. So at this point, I'd like to have Maria open up her microphone and let us know if anything's been coming in from a Q&A standpoint.
Hi. Okay. Thanks, Paul. Can you hear me okay? Just want to make sure.
Yes.
Okay, great. Yeah, we have a couple questions, but let me go with this first one from Dave in Tampa. His question was, how many intersections can be mobile scanned in a typical day of collection?
Yeah, that's a really good question from Dave. I think that's what's important to recognize is that it's really the answer to that question lies in two parameters. One is what is the density of those intersections, right? And then with that density, what's the accessibility? Think about the city of New York being very difficult to maneuver. And you have to imagine that we make more than one pass through the intersection to collect all the corners. So the density and accessibility would really derive the total number of intersections that we could get in a day. I think if you look at a typical urban area that has relatively good accessibility, we could easily get 50 intersections in a day. And then from those 50 intersections, you're talking about either 200 ramps or maybe 400 ramps, depending on the orientation. You may have 4 or 8 ramps per intersection. So you can see how on a given day, collecting 400 ramps at one time is a pretty significant effort with really not that much boots on the ground. So hopefully that answers Dave's question. But every situation is slightly different, and we'd be happy to talk in more detail about your particular needs. But you really have to think about what is the location like and how difficult is it to mobile map that location.
Okay, thank you. Another question is from Daniel. He asked, what were the margins of error between LiDAR method and conventional measurements, and were they similar?
Well, that's a really good question. To me, that's a question for folks that have done both. We are coming at this problem from a LiDAR perspective. We believe that we can produce very accurate results. And I think really that when you think about the accuracy, you have to look at the type of instrument because I think the word LiDAR is used a lot. And it's kind of become a blanket statement for any type of point cloud, but not all LiDAR instruments are created equal. We believe we have one of the best in the industry, and we produce relative accuracies for this type of application of about zero point zero 0.02 feet. So, you're going to get that's very hard to verify to say, well, it's not quite zero point zero 0.02 or it's zero point zero 0.01 or it's zero point zero 0.03, but very, very accurate results. I think that the problem with a manual method is that there's a lot of subjectivity to how the person puts a smart level on the ground. Are they truly measuring the slope across? Are they skewed a little bit? So there's some subjectivity to what they're doing. I believe what we're doing is very objective, and I think you will get the same result from ramp to ramp to ramp. You have a very consistent result from this methodology. I hope that answers the question.
Okay, thank you. Another question, this is from Matt, and he asked, what software is being used to assess the point cloud data and produce the tabular CAD outputs?
Yeah, well, we use a variety of softwares. The specific software for the ADA compliance is something called Topodot. Topodot is a software that runs only on top of MicroStation as a CAD platform. And then that work is done within the Topodot environment and produces either a MicroStation CAD drawing. It can produce AutoCAD files as well. And then we're producing from there a tabular output, a CSV file. And then again, that CSV file is very ubiquitous, can be taken into either Excel or any other type of analytics software. And then it also feeds our Esri world in the enterprise GIS side. So the analytics of it, though, taking the point cloud of measuring, it starts with Topodot running on top of MicroStation. I hope that answers the question.
Okay, thank you. See, Jose in New York City asked, can we provide to Mazer the measurement needs for the different types of ramps that we have to inventory?
Yeah, that's a really good question. So what we have found in doing this is that every location, every city, every county that wants to do this, they all have a different variety of ramps. They typically standardize on a handful of them. But what's interesting is that the software that we're using allows us to create the template that really mimics that type of ramp. And then, as you saw in that one image, we're able to snap the corners. So it's a little bit wider or it's a little bit longer. We're able to take that template of a shape of the particular ramp and adjust it to the physical conditions in the field. So that to answer Jose, that really the idea is that you would tell us these are the 10 ramps that we deal with on a regular basis, and we make templates out of those 10. And then from that, we are able to expedite the analytics side in the office.
Okay, I think that's it for the questions that I see through the chat right now. If anybody has anything, they could, we have like a few more minutes if anyone wants to send another question over, or if Paul, if there's anything else you want to add at this point.
No, I don't think so. I just want to thank everyone for joining us. I know it's tough to get together. We'd love to spend FaceTime with people and meet them in person, but we really hope that the webinars will be helpful. We're going to provide a handful of these. If there's again, I think you could email us if there's something you're interested in more detail. We would really be happy to entertain that. We could have a little bit of a private WebEx if you have a specific need for your entity. So that's something I want to offer is that this isn't just the broadcast is more like an opportunity to say, hey, we do this. If you're interested, we can help you. But if there is a particular need, that's something we can certainly take and do a private session, WebEx session with you in the future. So feel free to ask for that. There's nothing we wouldn't want to do more is to help folks with any problems they might have.
Okay.
Anything else come in, Maria?
I don't. There's one question, but I'm not sure if this is something that is too broad to answer. But I'll just posed a question. It's asked from, I believe it's from Justin, and he asked, do you have a ballpark cost per ramp?
Yeah, that's hard. That kind of goes back to the whole question about how many can you collect in a day. It really kind of depends on the situation. Um, I would hate to give you a number. Then we look at this. Here's an example. Someone says, "Hey, we have to do these 50 ramps, and they're 40 miles apart." So the process to collect is a lot different than if you had a concentration of ramps. So really, it's the solution that we're looking at doing, and it really starts with how do we collect the information, and what is it? Are there any specific templates that we want to develop? So all of these things kind of get figured into the cost of it. So it would be hard to give you a cost per ramp at this time. I would be more than willing to talk to Justin offline and say, okay, show me where your location is. What is the town, the city, the county? What are you trying to accomplish? And then we could take a look at, that as a holistic thing and provide a better estimate. But it's really hard to give an estimate, like a pricing estimate with a limited amount of information, I hope he understands.
Yes, seems reasonable.
Okay. All right. Anything else, Maria?
Um, no, I think that's it.
Well, that's good. We can let everyone get back to their day. I want to thank everyone again for joining us, and please stay safe. And we look forward to hearing from everyone again in the future.